Hi guys, in this video we are going to learn a brief introduction about diode. If you are new to this expert channel, don't forget to subscribe it. So first of all, we need to understand from which material these conductors have been introduced or have been made. The simple thing is it's only made by semiconductor materials. What's meant by semiconductor materials? When you are taking any kind of metals, we are going to call that metal as conducting materials because in a stable position of that atoms, the metal's atom, it's going to have some valence electron which is going to flow throughout the metal surface so that there is valence electron that can carry out the electron's charge throughout that metal surface. But when you are considering about the semiconducting material, let's say for an example, there is a silicon. So normally the silicon is going to have 4 valence electrons, which means in the valence shell, the final shell of that silicon atom, it's going to have 4 valence electrons like this. Likewise, every silicon atoms will have 4 valence electrons. So let's draw like this. And the beautiful thing is to be at the stable position of silicon, these two electrons, which means one valence electron from one silicon and another valence electron from another silicon, will get into a bond. So that it's going to have 8 electrons for one silicon. So that if it happens, it's going to be in a stable position. In this time, in this instance, there are no electrons, no free electrons, so that it can't be released to that surface, silicon surface. But in metal, the story is different. The metal is going, that atom is going to release some electron to be stable, so that there will be free electrons. But in silicon, like the semiconductors like silicon, there won't be any this kind of free electrons at the beginning. If you give a temperature for this silicon, what's going to happen is it's going to break some bonds. So let's say if these two bonds, if this bond is broken, these 2 electrons will be go outside the silicon, which means it will act as free electron, so that it will start to conduct electricity. So these kind of materials are known as semiconducting materials, and these types of semiconducting materials are used to make diode. That's the first thing you need to know. And here you can see, when we are using these semiconductor materials, we don't directly use that. Instead of that, what we will do is we will change to p-type semiconductor and n-type semiconductor. What's meant by the p-type semiconductor? So it's very simple. Let's say this is going to be a p-type semiconductor. How we are going to change the silicon, a semiconductor, to p-type semiconductor is we are going to do one process that's known as doping. The doping simply means inside, in between the silicon atoms, we are going to make, or we are going to insert an atom which is having only 3 valence electron. So if you put inside the silicon atoms, what's going to happen is, normally if there is a silicon, it will make the bonds between these 4 silicons valence electrons. But if there are only 3 valence electrons for boron, since that it's only going to make bonds with these 3 silicon atoms. So in this position, there is no one electron to make the bond with this silicon atom's electron. So in this case, what we are going to tell is it's going to be a positive, which means there is a absence of an electron. If you take the silicon from this side, and if you insert an boron which is having only 3 electron, it's going to make a positive. But remember, it doesn't mean it's going to have a positive charge. It doesn't mean like that. Normally, if there is a silicon atom, it should come. So in respective of that silicon atom, we are going to tell this is p-type. It's a positive type, but always remember it's not charged. So that's the main thing. In some exam questions, you might be seeing that they will tell that p-type conductor is a positive charged element. But remember, it's not that, because we are just having a positive, because if we think that if there is a silicon, it should have 4 bonds, which means it's going to have 4 electrons, so it will make a bond. But now there is only 3 electrons, so that what happened was there is an absence of electron, so which means absence of electron, so that we are going to tell positive p-type semiconductor. And the n-type is, you can easily guess what's meant by the n-type is, if we insert an atom which is having 5 valence electron. So if it's, let's say there is a element, let's say that is a germanium, so germanium is going to have 5 valence electron, but anyhow there can be only 4 silicon atoms can be covered by 1 germanium. So what's going to happen is the same story but different charge, which means it's going to have additional 1 electron which is not having any bond. So that what the electron can do is it can act as a free electron, which means it can go to that surface and conduct the electricity. So in this case, there is a positive, which means always remember there is not a positive charge. And what's there is, yes, it's very simple. We are going to tell there is a positive type conductor, which means in respective to silicon, there is a positive type. Likewise, in this case, if you consider the whole piece of this n-type conductor, it's not a negative charged, because germanium will normally have 5 valence electron. Likewise, silicon is going to have 4 valence electron. So the total number of electrons has not been changed. But always remember, if there is a silicon, what will normally happen is it's going to have only 4 valence electron. But now there is an extra 5. So there is one more negative. So compared to that, it's negative type semiconductor. So this piece is also not having any charges. Likewise, this piece is also not having any charges. But the thing you need to remember is there is a positive type, which means there is a hole. If there is a free electron, it can move to here so that they can make a bond. So we are going to call this place as hole. But in this case, there are no hole. What's here is it's going to be an free electron, which means it can go to another place. Because there are, the germanium is already in a stable position because it has covered an 8 electrons in the valence shell by having bond between those 4 silicon atoms which is covering that germanium, so that there is another valence electron which can be going to act as a free electron. So this is the concept between p-type and n-type. If you consider these things, to build a diode, what we are going to do is we are going to dope these two, the p-type conductor and n-type conductor, and we are going to merge that. If you merge that, normally what we will think is, let's say there is going to be, in another case, there is going to be germanium with silicon, and here it's going to be boron with silicon. So there is a hole. So what normally we will think is this electron will jump into this one and it will get into this hole. Whether it can be happened, the thing is it can't be. The reason is whenever the electron comes towards this side, this germanium is going to be positive. Actually, it's going to get a charge. The reason is in this part is not having another extra charge. It's having its own electron, so it should have 5 electrons. It's having 5 electrons in this time. If this electron tries to move to this one, what's going to happen to this germanium is it's going to lose his electron, so that it's going to get positive charge. So that's happened over here. If you put like this side, it's going to be plus. which means these electrons tries to go to this one. But the thing is, it can't move again and again, which means it can't be neutral. Like germanium and boron can't be neutral, which means the electron can't move to this boron directly. The thing is, the germanium is going to be positively charged, so that it will attract the electron again from the boron, so that there will be an depletion region. So that's the thing. So always remember, it might be sounds weird what's happening over here, but the thing is, it's very simple. If you merge these two, it can't get neutral, because if the germanium, if you take, it's very simple. Let's say if you are taking from your friend, let's say your friend is having so many pens. So let's say you will need a pen, so you are going to take this. Likewise, there is another pen, and he is trying to take from another guy. So if it's going to happen again and again, they already knew that you are not going to give their pen. So what they will do is they will resist to give their electron. So there will be a depletion region, so that another friends of the germanium won't give the pen to the boron again. So there will be plus again and minus in this side. But here it will merge some electrons will try to merge. So this is known as depletion region. So that's the basic introduction of diode. To do this diode, so to work with this diode, what we need to do is we need to provide positive side, so positive voltage to the plus side and the negative to the minus side, or n type of this diode. So we need to give positive voltage for the this p type, and we need to give the negative voltage for this minus side. If we give like that, what's going to happen is these minus will start to move to this side. This minus will start to flow from this side. The reason is, now they can have that germanium can have negative, they can attract electrons from this side, this minus supply. If you are not providing supply, they can't attract electron, so that they need to get the electron from the depletion region, from their own electron. But if you are giving an supply, they can directly attract the electrons from this supply. So that's going to happen. So if you are providing like this, it's going to get enough voltage, so that they will start to work, which means they will start to give the um, electricity flow through this, sorry, through this diode. So let's say you are connecting in other side. So here it's going to be plus anyhow in the beginning, and there is a depletion region, which means there are minus over here and plus over here, which means it's going to be neutral. In other case, which means the germanium electrons have been shifted to this position, and boron have got this electron, germanium's electron, in this region. For a certain region it can be done. After that they will start to resist. So here there's going to be n-type conductor. So if you are providing in the next side, like let's say you are going to provide positive supply for here and negative supply for here. So what's going to happen for this germanium is, the germanium's electron, the valence electron of germanium is going to be attracted from this side too. So already we have, it's going to be applied to this direction. Likewise, it's going to be applied for this direction too. So what's going to happen over this side is, the depletion region is going to become very thick. So let's say it's going to be like this. So if it happens, which means there will be a huge voltage across this, so that the current can't flow through this diode. So that's the thing you need to understand. So if you are having this plus, if you are giving this positive side to this negative NP, the N type of this semiconductor, what's going to happen is the electrons of germanium is going to be attracted from this side too. So there will be a huge resistance from this germanium side as well as the boron side, since there are negative electrons. So that the depletion region is going to be wide, so that they can't conduct this electricity through its diode. So now let's simplify the things, and you can't even draw these things in exams again and again, so that there is a symbol for diode. The positive side is going to be the p type of that diode can be represented in this side. In this side we are going to tell this is a positive terminal of the diode, and this is going to be the negative terminal of the diode. But remember, positive terminal means it's going to have p type. It's going to be like this is going to be p type, and this is going to be n type. There will be a depletion region. So there will be a voltage across this depletion region, which means if you are providing some voltage, let's say you are providing a small voltage, this is going to be plus and this is going to be minus. If you give in other way around, always remember that's not going to work. The diode is not going to work. If you are giving in this direction, there will be a voltage across this. Already there is a depletion region, so that there will be a resistance. So you need to give the supply voltage. The voltage should be higher than this resistance voltage, this voltage, otherwise it won't work. So always remember, let's say normally in silicon it's going to be 0.7 voltage at the depletion region. So when you are connecting this plus, you need to give at least 0.7 or little more than that to get a current through this diode. Otherwise it's going to be very small current only pass through this terminal. In the other case, let's say you are providing plus to this and minus to this p type, p terminal is not going to work. It's not going to allow the current through this diode. So that's the important thing you need to remember. So another important thing is, let's say there's a diode and you are giving this plus side, and for the minus terminal you are going to give the negative voltage. So in this instance is known as forward biased diode. The diode is forward biased, which means you have connected the diode correctly, which means the diode can work. If let's say you are providing like this plus and minus, in this case you have given in the wrong direction, which means in the p terminal you have given the negative voltage, so that diode is not going to work. We are going to give it a name that's known as reverse biased. So that will work on forward bias and won't work on reverse bias. And always remember, if there is a forward bias, we need to give the voltage higher than the resistive voltage by the diode depletion region. Otherwise, it won't conduct the current. I hope now you have got a little bit understanding about this. If you have any doubts, please comment in below. And I'm going to give an animation video links which is provided by another YouTube channel, so you can also get a clear understanding by watching that video also. Thank you for watching. Subscribe and stay tuned.